Hello everyone, I'm Abhishek and today we are analyzing the physics portion of JEE Main 2018 offline paper. Now, while solving each question, I will tell you what level of difficulty belongs to that question. And all of this is supported by sound data. I will also tell you different short tricks and different ways to reduce the time during the exam. So stay with me. Hopefully you will learn something new today and let's get started. So in this problem, the density of a material in the shape of a cube is determined by measuring the three sides of the cube and its mass. Now it has been given that the relative percentage error in measuring the mass of this cube is 1.5% and in measuring the length of this cube is 1%. You have to find out the maximum error in determining the density of this cube. So the concepts that are involved in this problem is just one, that is the error analysis, or you can say the propagation of errors. And if you're wondering about the difficulty level, then I would keep it under the easy category. So are you ready to solve this one out? Okay. So we know that the density of a cube or the density of anything is mass per unit volume, right? And the volume of the cube is going to be side cubed, that is A cubed. And we know that in such a case, the relative error d rho by rho is going to be equal to the relative error in the mass dm by m plus 3dA by A, right? And if you want percentage, then you can multiply it with 100 both the sides. Now we want to find out the percentage error or the relative percentage error in the density. So d rho by rho into 100 we want to find. And this is going to be equal to dm by m into 100. And what is the relative percentage error in measuring the mass of this cube? Well, that is 1.5%. So this is 1.5 plus 3 into 1%. Comes out to be 1.5 plus 3, that is 4.5%. As simple as that. So the relative percentage error in the density of the material is going to be 4.5%, and in this case we can take option C as the right answer. Now in this case, these four curves represent the same motion, but one of them fails to do so. You have to pick the odd one out. So the concepts tagged to this problem, or you can say this problem, is based on rectilinear motion and graph. And although the level of difficulty can be subjective, but the majority of the students found the level of difficulty of this problem to be medium. So how do you begin? Well, first let's take a look on this curve and try to think of a motion that is represented correctly by this graph. So assume a particle which starts from the origin. Okay. Now according to this graph, at t is equal to 0, particle has some positive velocity. And can you see that the velocity is decreasing at a constant rate with time, which suggests that the particle is experiencing constant retardation throughout its motion, right? The slope of this curve is negative and constant. And at this moment, the instantaneous velocity of the particle becomes 0. After that, the particle turns back and starts to move towards the origin, right? Now, can you think of such a motion? Well, I can think of a particle which is thrown in the vertically upwards direction with some velocity v. Can you see that the velocity time curve exactly matches the variation of velocity with time of this particle? As you can see, the particle would be experiencing the constant acceleration due to gravity in the downwards direction. So its speed will reduce linearly with time until it reaches the topmost point where its velocity will become zero. And in this curve, it is represented by this point. After that, the particle turns back and moves downwards towards the starting point. Right? Now let's take a look on the velocity position curve. Do you think this velocity position curve also represents the same motion? Well, in this case, think about some position in its journey. Well, at this location, the particle will have two velocities, one positive and one negative. The positive velocity will be attained when the particle is going upwards, assuming the upwards direction as positive. And at the same position, negative velocity will be attained when the particle is coming down. Now, can you see on this curve, at one position, you have two values of the velocity, one positive and the other negative, with the same magnitude, right? And when the particle reaches the maximum height, the velocity is zero, which is represented by this curve. This means that these two curves are coherent and they both represent the same motion, right? Now the conclusion is that one of these two curves is the odd curve. That is, one of these two doesn't represent the same motion that we are talking about. So which one do you think it is? Well, we are not doing the guesswork, right? We are trying to analyze it. So let's look at this graph. Do you think if a particle is thrown in the vertically upwards direction that we have assumed, then the position time curve of that particle is going to look like this? Well, the curve should be parabolic. Why? Well, if I use the second equation of motion to relate the position and time, because we have assumed that the starting point is the origin, right? In this case, the position time curve and the displacement time curve will look exactly the same, right? And the second equation of motion says the displacement is going to be equal to ut minus half gt square. And this equation is quadratic in time. So the parabolic shape is justified. But do you think that the position time graph is right? Well, the same position is reached at two instants. One while going up and the other while coming down, right? And at t is equal to 0, the particle is at the origin. And when it is again at the origin, then the time is this. So this graph also makes sense and corresponds to the same motion, right? This leaves us with this one as the incorrect depiction of this motion. But let's go further and try to analyze it. If you take this position time curve, then with the help of this, can you plot the distance time curve? Well, if you remember, then we used to obtain the distance time curve from the position time curve by taking the reflection of this part with the horizontal. And the reason is that distance can not reduce as far as the particle is in motion. If the particle moves, the distance will only increase, right? But this is the position time curve. And at this moment, we know that the particle has reached the maximum height. And when it starts to come down, the distance will increase. And that is why you will attain the distance time curve from position time curve by taking the mirror image of this declining curve. So it is going to look like that. And now you can see what's the inconsistency, right? The distance time curve for the mentioned motion should look like that, and not what has been given. Make sense, right? So I hope you understand the logic in this case, and from here we can see that the distance time curve is the wrong depiction of the same motion, which is represented by the other three curves. So in this case, you can take option B as the right option. So in this setup, M1 is given as 5 kg and M2 is 10 kg. The coefficient of friction between M2 and the surface in contact is 0.15. You have to find out the minimum value of the mass of a block that should be kept on top of M2 such that the blocks do not move. And then you have to choose the right option out of these given options. So the concept involved in this case is friction. And the difficulty level, I would say, is easy. Now, how do you proceed in solving this one out? Well, first let's focus on the block M1. Let's assume that the tension in the string is some T. So the tension is pulling this block in the upwards direction and the force of gravity is acting on it downwards. And when this block is not accelerating, then you can see that tension must be equal to M1 into G, right? M1 is 5, so this is going to be 50 Newton. And now let's focus on these both blocks as one system. On the system, the tension is acting on it towards right, and the friction force is acting to the left. Now can you see, if you want these blocks to not move, then the limiting friction force must be greater than equal to the force of tension, right? And the limiting friction force, you know, is going to be equal to mu into N, where N is M plus M2 into G. So this is going to be mu M plus M2 into G, and this should be greater than equal to the tension force, that is 50. Now this will be gone, and now we can put the value of mu as 0.15 M plus, and this is 10, and this should be greater than equal to 5, right? And can you see from here, you have the value of M plus 10 to be greater than equal to 5 divided by 0.15, that is 33.33. And this means that M should be greater than equal to 23.33 kg. Yeah. So the value of the mass of the block that should be kept on top of M2 should be greater than equal to 23.33 kg. Now look at the options. Can you see that the closest call is 27.3 kg, right? And therefore option B is the right answer. So we can take option B as the right one for this conceptual problem. In this case, a particle is going in a circle and the potential energy function of this particle depends upon the radius like this. So U is equal to minus K divided by 2R square. You have to find out the total energy of this particle and then choose the right option. So what do you think are the different concepts involved in this case? Well, I can think of centripetal force and energy. And the difficulty level of this question, I would say, is easy. Now you know that you can find out the total energy by taking the summation of the potential energy and the kinetic energy of the particle at any moment. So the question boils down to finding out the kinetic energy of this particle, or you can say the kinetic energy function. Now can you see that the potential energy function is defined? This means that there would be a conservative force acting on this particle which is making it go in a circle, right? Because you can only define potential energy function corresponding to a conservative force. And how do you find out that force? Well, we know that force is going to be equal to minus du by dr. So let's find out the force here. F is going to be equal to minus d by dr of the potential energy function, that is minus K divided by 2R square. And this comes out to be, so K by 2 is a constant, will be pulled out. So this is simply d by dr of r raised to the power minus 2. Comes out to be minus K divided by r cubed. Now can you tell me what does this minus sign indicate? This negative sign indicates that this force is acting towards the center of the circle in which the particle is going, right? And the magnitude of this force must be equal to the centripetal force, that is mv square by r. Yeah? So this force is providing the centripetal force, and we can say that mv square by r must be equal to K divided by r cubed. Correct? And from here you get the value of mv square by 2 as K by 2 into r square. And this is the kinetic energy. And now all we have to do is add K by 2r square to minus K by 2r square to find out the total energy. And can you see? This comes out to be 0. So we have in this case the total energy to be equal to 0, and you can tick option C as the right answer. When you encounter standard problems in the competitive exam, you feel good, don't you? So in this case, an electron, a proton, and an alpha particle having the same kinetic energy are moving in circular orbits in a uniform magnetic field. You simply have to relate their radii. So the problem based on magnetic field is an easy one. So you know that radius is equal to mv upon qb, right? Where mv is the linear momentum, that is p. But the linear momentum is not constant. The kinetic energy is constant. And we know that k is p square by 2m. Using these two, we have the standard formula for radius, that is under root 2mk divided by q into b, where k is constant and b is constant for all three particles. Now can you see that the mass of the electron is really small, And undoubtedly, the radius of the circular path performed by the electron is going to be the least. Yes? Now let's talk about the proton and alpha particle. So the charge on the proton is going to be E. So this is a proton and alpha particle. So charge is E, and the magnitude of charge on the alpha particle, which is the nucleus of the helium atom, is 2e, right? And if you assume the mass of each nucleon to be m, then the mass of this proton is going to be m, and the mass of the alpha particle is going to be 4m, right? And can you see from here, the radius of the proton and the alpha particle will come out to be the same, right? So in this case, we have the relation, and can you see that option B is the right option? The magnetic dipole moment of a circular wire is doubled without changing the current. You have to find out the ratio of the magnetic field at their centers. So easy problem based on magnetic field, right? Now we know that the magnetic dipole moment is I into A, and for the circular wire it is going to be I into pi r square. Now think about this. The magnetic moment is doubled without changing the current. This means that the radius has become root 2r, right? So this means that R2 is root 2 into R1, and we know that the magnetic field at the center is going to be mu naught I divided by 2R. So B1 is mu naught I by 2R1, and B2 is mu naught I by 2 root 2 R1. Taking the ratio B1 is to B2, we get root 2. And that's it. So in this case, option C is the right answer. You simply have to find out the Q factor of this RLC circuit. You know that the Q factor is defined as the ratio of the resonant frequency to bandwidth. And this is a direct formula based question, which is really easy. In this case, we know that the Q factor is going to be omega naught L by R. As simple as that. So in this case, let's quickly choose option A as the right option.